Hi everyone, in this video I'd like to talk about limits. So the idea of a limit, it's a value that we approach. So I'm just going to draw a little graph over here before we get started with the real problem we're interested in. And suppose I've got a graph in the XY plane, and maybe my curve wiggles around and then it comes in as X approaches. We'll make that 2. It comes into this open circle, which is located up 1 unit. And then on the other side, I'll make it a solid circle. It wiggles around and shoots off to infinity. So the idea with a limit, this is a piecewise function, and the idea with a limit, so I'm going to say the limit as x approaches 2 from the negative side of my function. That means if I was a little insect, I'm going to draw an ant over here or a cockroach or something like that, and I was way over here on the negative numbers, and I start marching in, and I'm headed towards 2, and I'm marching in towards 2 from the negative side. What value do I approach for the y-coordinate? Well, as my little ant comes in from the negative side and I'm approaching x equals 2, as I approach that, my y value gets close to 1. Now, on the other hand, if I come in from the other side, so let's take the limit as x approaches 2 from the positive side. So that means put yourself way out there at positive infinity. Let's pick a different color. Here's another bad drawing of an insect. I don't know what that's supposed to be. A caterpillar? I don't know. Anyways, I'm way out here at positive infinity. In I come. I'm headed towards 2. I'm never going to get there, but I'm going to get really, really close. So I'm crawling in. As x approaches 2, what is my y value? Well, it's certainly not 1. There's a big jump here. I don't know what the y value is. It's kind of a made-up graph. Maybe that's a 3. So this little ant coming in from the positive side, that y coordinate would be 3. So you can see when we come in from the left-hand side or the right-hand side, we're getting very different answers. And so in this case, we would say the two-sided limit does not exist. And it doesn't exist because our two hands don't meet up. You know, you want your left and your right to come in and say hello, shake hands. They don't do that. They don't meet. My little bugs here do not meet. One's way up high, one's way down low. And so the two-sided limit does not exist. So if somebody says, hey, find me the two-sided limit as x approaches 2 of f of x, notice I don't have any superscript with the plus or minus. That means it's a two-sided limit. I would say, sorry, but it does not exist. Now, the function has a value. There is a closed circle there. In other words, when x equals 2, f of 2 is 3. The point 2, 3 does exist on the graph, but when we talk about limits, we're talking about trends. And the trend, if I come in from the negative side, is different than the trend if I come in from the positive side. All right, so let's go to more of a homework problem, which I've drawn over here on the left side of the graph. But I'm going to keep this visualization in my mind of these little insects crawling around on my graph. Or if that's disturbing, you can think about, a person going for a walk. It's probably less concerning, especially if you've lived in the tropics. You've seen some really big bugs in your life. Anyways, the first one I'm going to look at is over here. So I want to know about the limit as x approaches -4. Now, this is a question about the two-sided limit. And in order to really figure that out, I need to come from the left. So let's take a look at the left-hand limit. The limit, as x approaches -4, if I start over there on negative infinity and march myself in towards x equals -4, here I go, I'm coming in, I've started way over on the negative side of things, and I'm heading in towards x equals -4, and certainly my y coordinate is heading towards 0. That's great. And if I look at the right-hand limit, this would be the limit as x approaches -4 with the superscript plus. So that means I'm coming in towards the -4, but I've started over on the positive side of the graph, on the right side. So I'm coming in, and the y coordinate looks like it's heading towards 0. And so, since the left-hand limit equals the right-hand limit, the two-sided limit, yes, it exists, and it is exactly 0. Okay, let's do another one. Let's take a look at, I'll get rid of all of this. Let's take a look at the limit. So the next question will be, the limit as x approaches 0. So again, this is a question about the two-sided limit. So let's look at the left, let's look at the right, and see if they match up. If they don't match up, we're out of luck. We don't have a two-sided limit. All right, so the left-hand limit, we are looking at the limit as x approaches 0, and we're going to come in from the negative side. So there's x equals 0. I'm coming in from the negative side. X is trending towards 0, and the y coordinate is heading towards -5. On the other hand, if I come in from the right and I'm headed towards x equals 0, my y coordinate is trending towards y equals -2. These two values are not equal, so the two-sided limit does not exist. So I'm going to write DNE for does not exist. Now, we could ask another question here. Let's do that. Just do one more. Oops, let's get rid of that. Okay, so one more question I'm going to ask you, and here it goes. I'm going to say, what about the limit as x approaches 1 of g of x? So let's see, here is the value 1 on my graph. So I'm going to come in from the left as x approaches 1. Looks like my y coordinate is a -2. Similarly, if I come in from the right, my y coordinate is -2. The left and the right are equal. My two-sided limit exists. Now, what's very different about these cases, it's whether the function exists at those points. So let's go through and ask a slightly different question now. I want to ask you, what is g of -4? In other words, what is function g evaluated at the point when x equals -4? What's the y coordinate? That's what I'm asking here. So if I look at my graph, let's see, when x is -4, I've got an open circle there on that graph. So the function's not defined at -4. There's an open circle. There's a hole. So the function does not exist. All right, let's look at a different question, which is, what is g of 0? In other words, when x is 0, what's the y coordinate? So if I look here, when x is 0, I'm right here on the y-axis. We've got an open circle down there. We've got an open circle up here at -2. But we do have a closed dot here at y equals -3. So that means when x equals 0, the function is defined, and the value is y equals -3. That's the power of the closed dot. We actually know what the function is. And now let's look at this one down here. What is g of 1? Well, this is absolutely lovely, because when g of 1, we have this nice solid line here So there's no ambiguity, nothing really tricky to figure out there. We know that the y-coordinate is -1. When we go to talk about continuity, when the two-sided limit is equal to the value of the function, this means you have a continuous function, or the function is continuous at that point. And it's continuous because, if I was driving my car along, or I was an insect trying to crawl along, this is a nice continual path. I'm not going to fall through a hole in the road like a pothole. I'm not going to shoot off to infinity or fall off a cliff or do anything weird. I am driving along a nice, smooth, continuous path. And so that makes intuitive sense. This is not continuous because the two-sided limit doesn't exist at x equals 0. So this is a not continuous. And I can see, certainly I'm falling off a cliff. That would not be a good road to drive on because it's not continuous. You're going to just fall right off the cliff there. And then this is also not a good situation if I'm driving or walking maybe. Actually, this happened to me this summer. I fell in a pothole, sprained my ankle. So if you're walking along, if you're an insect or you're me walking along, and there's an open circle, there's a point that's not defined, and you fall down in the hole, that's not a continuous path. So this is not continuous. And again, the reason it's not continuous is because the two-sided limit doesn't equal the value of the function.